$17,584. Take a moment. Let that number settle in the back of your mind. It isn't just a figure on a balance sheet. It is the sound of American taxpayer wealth evaporating into the stratosphere. Every 60 minutes, a Boeing F/A-18 Super Hornet remains airborne. Look at this machine. To the uninitiated, it is a masterpiece of kinetic violence, a sharp-edged silhouette of power designed to scream at Mach 1.8 and crush its pilot into the seat with 7.5 Gs of centrifugal fury. It is the undisputed heavyweight champion of the flight deck, an apex predator engineered for one cold hard purpose: air dominance. But if you were to walk into the Carrier Air Wing office on the USS Ronald Reagan or the USS George H.W. Bush today and pull the flight operations logs, you would find a statistic that defies every law of economic and military logic. Between 20 to 30% of every Super Hornet sortie flown in the modern Navy is not a combat mission. These pilots aren't hunting MiGs, they aren't prosecuting surface targets or dropping precision-guided munitions. Instead, they are flying in slow, agonizingly lazy circles thousands of feet above the dark swells of the ocean with a long rubber umbilical cord trailing out of their bellies. We are taking a $70 million supersonic interceptor, a weapon designed to win the Third World War, and we are using it as a flying gas station. In any other industry, this would be an absurdity. It is the strategic equivalent of purchasing a Ferrari, Formula One car, stripping out the passenger seat, and using it to deliver pepperoni pizza. To the accountants in the hallowed air-conditioned halls of Washington, it looks like institutional insanity. It looks like a logistical nightmare that has spiraled out of control. But here we do not look at the polished spreadsheets. We look at the blueprints, and when you study the blueprints of modern naval warfare, you realize that this staggering waste isn't an accident of bureaucracy. It is a desperate, calculated survival mechanism. We are burning the fatigue life of our premier fighter fleet. We are quite literally eating our own young because the alternative is obsolescence. We are engaged in a war against an enemy that doesn't care about our budget, our politics, or our pride. That enemy isn't a nation state, it isn't a flag. The enemy is geometry. To truly grasp why we are systematically destroying our best fighters in the sky, you first have to understand the claustrophobic chaos of the world they inhabit on the ground, or rather on the steel. The flight deck of a Nimitz-class carrier is often described as 4.5 acres of sovereign American territory. To the civilian eye, it is a display of ultimate power. But to the handler, the officer perched in the tower responsible for every inch of movement on that deck, it is a high-stakes prison. On this deck, space is the only currency that matters. Every square foot is calculated in blood and efficiency. If you misplace a single yellow tractor, you stall a launch. If you park a jet 3 inches over the foul line, you shut down the runway. It is a game of Tetris, played with 30-ton blocks of high explosives and jet fuel. And in this game, there is one particular piece that ruins everything: the E-2D Advanced Hawkeye. The pilots call it the Hammer because of the low constant drone of its twin turbo props, but the deck crews, the men and women in the colored jerseys who have to move it, have a different name for it: the deck clogger. Look at the dimensions and you'll see the friction. An F/A-18 Super Hornet has a wingspan of about 44 feet. It is sleek, compact and manageable. The Hawkeye, however, stretches over 80 feet. Even with its wings folded, it is a massive monolithic block of aluminum that dominates the catapult track. When the handler spots a single Hawkeye on the waist, he loses the real estate required to launch 2 or 3 strike fighters. It is a geometric bottleneck. But size is only the beginning of the headache. The real issue is that the Hawkeye is a prisoner of mid-century engineering. Modern jets like the Hornet or the F-35 are self-sufficient. A pilot hits a switch, the auxiliary power unit, APU, kicks on, and the engines scream to life. They are autonomous. The E-2D is not. It lacks an onboard power unit capable of starting its own engines. It is helpless. To wake this beast up, the deck crew has to drag over a hopper, a massive mobile electric power plant. They have to physically drive this tractor to the aircraft, drag heavy umbilical cables across the non-skid surface and plug it in. This creates a phenomenon known as tethering. The E-2 cannot just be parked anywhere. It must stay within leash distance of a power hatch or a hopper cart. It becomes an anchor, a concrete block in the middle of a flowing river of steel and fire. And then there are the windmills of death, those massive 8-bladed NP2000 propellers. When those blades start turning, they don't just move air, they slice through the safety protocols of the entire deck. The prop arc creates a lethal exclusion zone. You cannot drive a tractor past it, you cannot tow a fighter jet past it. When a Hawkeye is turning, the arteries of the carrier are severed. Traffic on the bow grinds to a halt. Because of this, the Navy developed a doctrine that is as brutal as it is necessary. If you watch any launch cycle, the first plane to shoot off the deck is almost always the E-2. People assume this is purely tactical, that we need the radar in the air to scan for threats. That is only a fraction of the truth. The reality is simpler. The handler wants it gone. He needs that 80-foot wall of aluminum off his deck so he can actually start the war. Until the Hawkeye is airborne, the carrier is choked. Only after it launches can the deck breathe. Only then can the fighters move. But once the deck is clear and the fighters are airborne, a much larger nightmare begins to unfold. Because now we have to look at the ocean. And in the last 30 years, the ocean has grown significantly larger than our missiles. To understand how we got here, you have to look back at the 1980s. The deck of a Cold War carrier was a diverse ecosystem. It wasn't just Hornets, it was a zoo of specialized aircraft. You had the A-6 Intruder, a dedicated long-range bomber. You had the KA-6D, a tanker version built solely to feed the fleet. You had the S-3 Viking, a submarine hunter that doubled as an incredibly efficient gas truck. These planes were specialized. They were often ugly, but they worked. Then the Soviet Union collapsed. In the triumphalism of the 1990s, the Pentagon grew arrogant. We looked at the budget and decided we didn't need a zoo anymore. It was too expensive to maintain so many different types of engines and airframes. We decided to simplify. We retired the Intruder. We retired the Viking. We threw away the very tools that gave the carrier its reach. We bet the entire farm on one horse, the F/A-18. We convinced ourselves that one plane could do everything: dogfight, bomb, jam radars, and carry gas. It was the doctrine of efficiency. And for a while it worked. It worked as long as we were bombing insurgents in the desert who had no navy and no air force. But efficiency is the silent enemy of effectiveness. While we were celebrating our cost savings, our adversaries were studying our math. They looked at our carrier decks, saw nothing but short-range fighters, and they began building a weapon specifically designed to exploit that arrogance. Enter the People's Liberation Army Rocket Force and their DF-26 Guam Killer. This is not a dumb rocket. It is an intermediate-range ballistic missile that can hunt a moving aircraft carrier from space. Its range is 2,500 miles. That is the radius of the kill box. To survive, an American carrier must stay outside that ring. If a captain sails inside that line, he is gambling 5,000 lives against a saturation attack of hypersonic warheads. So the carrier stays back. It sits in the sanctuary 2,500 miles away, but our primary spear, the F-35C, has a combat radius of only about 650 miles. Do the math. There is a gap of nearly 1,900 miles, a void of open water. If we cannot bridge that gap, the most powerful warship in history becomes a floating airfield to nowhere. It becomes a sword that is too short to reach the enemy's throat. This brings us to the logistical chasm. The gray space where the mission either succeeds or vanishes into the waves. To bridge this gap, the Navy relies on a tactic called mid-course staging. It is a desperate dance of fuel and physics. The carrier sits safely at mile 0. The F-18 tanker and the F-35C launch together, climbing into the sky as a single unit. They fly out 500 miles into the gray zone. At this specific range, they are still shielded by the curvature of the Earth. They remain below the horizon of land-based radar systems. To the enemy, the ocean is empty. At the 500-mile mark, the F-35 connects to the Super Hornet. It drinks until its internal tanks are at 100%. Then the split happens. The F-18, now lighter and low on fuel, turns around and heads back to the carrier. The F-35, topped off and effectively 500 miles closer to the objective, pushes into the kill box alone. It is invisible, lethal, and now has the range to strike. Tactically, it is a brilliant solution to a geometry problem. But physically, it is a catastrophe for our fleet. To understand why this tanker tax is killing our fighters, you have to look past the sleek grey paint and dive into the molecular structure of the metal itself. You have to understand the sheer physical violence an F-18 endures when it is forced to act as a truck. It starts with the 5-wet configuration. When a Super Hornet is designated as a tanker, it is loaded with 5 massive external fuel tanks, 4 under the wings and 1 under the belly. At this moment, the aircraft is operating at its absolute maximum carrier takeoff weight. It is an Olympic sprinter trying to run a race while carrying a refrigerator on its back. And then we shoot it. In just 2 seconds, the steam catapult accelerates this massive block of overstressed steel from 0 to 165 knots. The forces are immense. The inertia of all that heavy fuel wants to stay still, while the catapult lunges forward. These two forces fight a brutal war in the center of the airframe. The victim is the keel beam, the titanium spine of the aircraft and the wing roots where the heavy fuel pods are anchored. Every 5-wet launch twists and compresses this skeleton with a violence that no computer simulation can fully mitigate. But the destruction doesn't end once the wheels leave the deck. The next enemy is parasitic drag. To refuel another jet, the Hornet must extend a hose and a drogue basket. That basket looks small, but at 300 knots, the rushing air turns it into a monster. NASA wind tunnel data confirms that the drag from the drogue assembly alone generates nearly 450 pounds of constant backwards pull. Imagine tying a parachute to your waist and trying to run a marathon. For the entire duration of the mission, there is an invisible hand yanking the tail of the airplane backward. This creates constant low-frequency vibrations that rattle the airframe down to its very rivets, weakening the bonds of the metal hour after hour. However, the real assassin, the one that truly breaks the machine, isn't the launch or the drag. It is the heavy trap. In a perfect world, a tanker flies out, gives away all its gas, and returns to the ship line. But war is chaotic. Sometimes the mission is scrubbed. Sometimes the F-35s don't need the fuel. In those cases, the tanker returns to the carrier full. It is still carrying thousands of pounds of unburnt heavy kerosene. It is sluggish, heavy, and difficult to maneuver. An arrested landing on a carrier is essentially a controlled car crash. The pilot doesn't flare or land softly. He drives the jet into the deck at full power to ensure he catches the wire. When a 5-wet Super Hornet slams into that steel deck, while still carrying its heavy load, the kinetic energy transfer is catastrophic. The shockwave travels up the landing gear and shatters through the airframe. Engineers calculate aircraft life using a fatigue index. Flying straight and level is a 1, slamming a heavy tanker onto the deck is a 10. A single heavy trap does 10 times more structural damage to the lifespan of the jet than an hour of normal combat flight. We are taking a precision instrument, a violin, made of titanium and carbon fiber, and we are using it as a battering ram. Eventually the metal gives up. Micro cracks appear invisible to the naked eye. The aluminum fatigues. A jet designed to last 6,000 hours begins to die at 4,000. We are grinding our own sword into dust just to keep the edge sharp enough for today. Faced with this reality, the United States Navy was forced into a corner. There were only 3 moves left on the board. Option A, stop the tanking missions entirely, which effectively renders the multi-billion-dollar carrier strike group a decorative target unable to reach the enemy. Option B, buy an entirely new fleet of aircraft, a process that takes decades of bureaucratic infighting and trillions of dollars. Or option C, perform radical structural surgery on the survivors. They chose surgery. It is known as the Service Life Modification SLM program. This is the bill for 3 decades of strategic complacency finally coming due. Boeing has been awarded contracts that will eventually total over $7.8 billion. But understand this program isn't about building new advanced weapons. It isn't about adding lasers or new stealth coatings. It is about resurrection. We take these tired, beaten down Super Hornets aircraft that have been tanking since the mid-2000s and we strip them down to their bare titanium skeletons. Maintainers rip out the internals. They inspect every square inch for the microscopic spider webs of corrosion and the jagged lines of fatigue cracks. They replace the massive keel beams. They reinforce the bulkhead. They are for all intents and purposes rebuilding the aircraft from the inside out. The goal? To artificially extend the life of the airframe from 6,000 hours to 10,000 hours. The cost roughly $10 million per aircraft. That is the tanking tax. We are spending nearly $8 billion just to repair the damage we knowingly inflicted upon ourselves because we threw away our specialized tankers 30 years ago. We are paying billions for a band-aid on a self-inflicted wound. So the next time you see footage of a Super Hornet refueling another jet over the whitecaps of the Pacific, look closer. Don't just admire the engineering of the mid-air connection. Look at the hose. That hose is a lifeline for the F-35, but it is a parasite for the Hornet. It is sucking the structural life out of the host. Every gallon of JP5 transferred is a minute of flight life subtracted from the tanker's future. To the critics and the accountants, this looks like a systemic failure. They see a cycle of waste and inefficiency. They demand to know why the MQ-25 Stingray, the new unmanned tanker drone, isn't already on every deck. The answer is the most brutal part of the calculus. Even if production ramps up today, full fleet replacement is years, perhaps a decade away. You cannot fight a war with prototypes. The drones are not ready, and the friction of geopolitics does not wait for a research and development schedule. Right now, an American commander in the Pacific has to make a choice every single morning. He can save his planes and lose his reach, or he can burn his planes to hold the line. He chooses to burn them. This is the engineering trade-off of modern power. We sacrifice the tactical longevity of the machine to ensure the strategic survival of the nation. We trade metal for distance. We trade dollars for deterrence. Peace is not a static state, it is a commodity paid for in fatigue cracks and shattered kill beams. It is paid for by the maintainers working 20-hour shifts to keep overstressed birds in the air. This is the reality of the Pax Americana. It isn't a miracle of technology, it is a grinder, and the A-18 Super Hornet is the grist for that meal. It is dying a slow, expensive death so that the fleet can live. That is not a mistake, that is the discipline of power. War is often remembered by the explosions, but it is decided by the math of the mundane. If you have the stomach to look at the real cost of freedom measured not just in lives but in tons of stressed titanium and billions of wasted dollars, then you understand the burden of the watch.